Today we're going to explore two new chapters in the fuzzing book that are going to show you that test generation is more than just creating strings. These strings have a meaning. These strings can actually be used to interact with complex applications. And specifically, we're going to look into testing and remotely using web applications. First, we're going to go through the HTTP protocol interface, which is for this chapter. And for the next chapter, we're going to look into how to remote control a web browser to actually also handle all sorts of GUI interactions. So, our topic for today is testing web applications. And the idea here is that we do have a web server somewhere in the web. The web server here can be, well, precisely that, web server, but the techniques that we present in this chapter can also be extended towards other kind of servers. And what we're building here is a little server that actually allows you to buy fuzzing book promotional material. It's unfortunately it's only a toy server, so there's not too much you can do with it. And here we see some of its HTML in action. So this is what the order form of our fuzzing book server actually should look like. So we have a form where you can enter your name and your email and your actual address, and you can also choose between 3 items: a t-shirt, a rotary hammer, and a lock set. If you order 1,000 of these, I'll actually be happy to produce these for you. And if you have read the terms and conditions, then you can click on this and then you can actually place an order. So this form that we're seeing here is just HTML code that is being rendered by our browser. Our web server for this doesn't actually run yet. And we're having quite a number of extra forms, all the stuff that you need in order to run your own web server. We have terms and conditions. We also have a database in which we store all the orders. And then we built for the web server, we built a handler for HTTP requests, which takes care of orders at an URL/order, at an URL/terms and conditions, and other stuff. So plenty of stuff that we are building up first. And of course, there's also a handler for web pages that do not exist, the classical 404 HTTP error. And we also have an internal server error, just in case that somebody manages to crash our server. Okay, and we're also logging these things, and we will also be able to see all the individual messages of our server. So, let me see whether I can actually manage to run the server, which I'm going to do right now. So let me see, we're going to execute everything up to that line in our code. So this is all in Jupyter Notebooks. This works actually better in Jupyter Notebooks than if you're working just with code alone, because, well, Jupyter Notebooks allows you to render the HTML. It looks as if we have been able to start our server. And now I can actually run the server. Here it is. Yes. So at the address 127.0.0.1 at the port 8800, I now have a server running. Unfortunately for you folks, this server is not available publicly because this is just the address of my localhost. What I can do though is, I should be able to do this. I can take this address. I can actually also click on it, but I'm not sure what happens if I click on it. So I'm just going to copy it. And I'm going to copy this right away into a web browser, into the address over here. And then I should be able to see our server. Now I have my own web browser running. How cool is that? I can build a web browser in Python. By the way, the Python documentation says don't do that, because the web browser that you are building here in Python is anything but secure. But for demonstration purposes, it's going to be just fine. So what are we going to order? Let me see. We have, say, Marius over here. Marius Smutzek, sorry. Marius, no, just Marius. Marius, and this is of course Marius at cispa.de, and of course he lives in the beautiful city of Saarbrücken near Cispa. Oops, doesn't work. What's up with the zip code? This is interesting. Okay, apparently Chrome interprets it as a numerical value, so I can now enter the zip code by, in this case I need the zip code 66111, which means that I now have to press 60,000 times on that thing. Very interesting, all the various things that you can do with HTML. Okay, oh no, sorry, what did I do? This is Saarbrücken, this is how it works, and here this is where I enter the zip code. And I really cannot, oh no, I can also enter the zip code manually finally. Okay. I was already nervous because of that thing here. And Marius, have you read the terms and conditions? I think you have. And now I can go and place an order in here. And then Marius is going to get one Fuzzing Book t-shirt. And we already see that our server has a couple of deficiencies because it doesn't really well handle Unicode in here. Confirmation emails will be sent at Marius at Cispa. Marius, you're going to get things very soon. What else do we have? We can also send Marius a Fuzzing Book rotary hammer, and then Marius is going to get an excellent tool for trying out lots of configurations in a short time, and breaking into things. Rotary hammers are absolutely good at that, and of course a lock set for doing this in a more elegant way. Yeah, Marius, you're going to get plenty of swag. How do you like that? That's actually going to be fun. Okay, so this is what we have with, this is how we can place orders. Okay, and then we have, oh, we even get more orders. How cool is that? Is there anything else we can do on that page? Let me see. I'm just going to enter some URL, maybe order status or something. How close is the package to actually getting to us? I'm afraid this page does not exist, and we can go to the order form instead. And I think, well, we also have the terms and conditions in here, and the terms and conditions is not very exciting either. So this is what we have. We have a web server. So next interesting question is, now that this web server is up and running, how can we interact with it? And the way we interact with this, we're actually going to go and automatically synthesize requests, HTTP requests, that fill out that form automatically and automatically try out one value after the other. By the way, we don't have to necessarily switch from left to right here. We can also just run this in the Jupyter notebook itself, which is super cool. So if everything works well, we can actually see this thing over here. No, we can't. I'm so sorry. We have to still let this run over here. It is used to work. Okay, we have a regression. And we can also look up the messages that our server is printing. So here we actually see the individual get statements. This is what we get when somebody retrieves a page. And we also, interestingly, also see here the interaction with our database. So we see that a guy named Marius just has ordered a t-shirt to be sent to Saarbrücken at marius@cispa.de. And we can also go and actually fetch those orders from the database, and this is already the set of orders that we do have in our database. Actually, we can also go and clear the order database again, and now we have executed the whole thing, and now the actual order list should be empty. Marius, I'm so sorry you're not going to get any Fuzzing Book swag anytime soon. Okay, so we do have the opportunity now to actually look at individual contents in here. So when we go at contents and invoke web browser with this particular URL, what we get is a variable named contents, which actually contains HTML code for the page that we're currently having, and so which we can then render. And this is again what we get for the current status of the what we get for the current status of the page. And using this URL, we can also retrieve other inputs, other web pages. Well, again, we have status, which is not super interesting. And if we tell that to the browser we want a page named status, then we're going to get, same as before, a 404 page telling us this page does not exist. And using this web browser function, by sending this web browser function one URL after the other, we can actually try out the functionality behind that web browser by simply enumerating the possible URLs through which we can access the browser. So here we go, and again we do have our original start page where we can put the orders in. So now we could of course go and try to guess the individual URLs through which we access the server, but it's actually much more fun to do so automatically. And for this, we actually go and analyze the HTML that we're having here. Oh, it's actually auto-filling things. How neat is that? We're looking at the HTML of the page that we're seeing here in order to find out what the input fields are, how they're being named, and also what the buttons are, notably this place order button, and where this leads us. So you can already see here in the HTML source code, for instance, here we have an input field which has a type of email, very convenient, and whose name is email. We also do have an input field whose type is text and where the name is city. And we do have a submit button which submits the entire form, and when the form is being submitted, then we go to the next URL, which is /order. And if we now extract this information from our HTML page, then we can go and synthesize orders ourselves. So the idea is to analyze the contents of this HTML page, synthesize orders, and thereby fuzz the server like crazy with all sorts of synthesized orders. If you ever wanted to order plenty and plenty of things from Amazon, for instance, here's the tool to use. Except that, unfortunately, at Amazon you also have to provide a credit card or something, or some payment, and unfortunately there's no way to use this to order things from Amazon without also having to pay for them. Sorry, no free lunch for you. But just in case, this may be helpful if, say you are an American president and you absolutely need 36,000 votes in order to get the election shifted in your direction. Well, why not go and find out whether you can synthesize the 36,000 votes automatically? Just a thought. If only our American presidents would know more about fuzzing. Well, maybe we shouldn't tell them. Okay, good. So, and these are now things which we now can use. So, for instance, we can go and send out individual orders. Oh, sorry, we still need to get there. I need to execute these things one after the other. So let me get in here and in here and in here. So we're executing all these things, and now we are Now we are synthesizing these things. And what we do now is we are implementing not very surprising here again, we can implement a grammar that actually takes various values for these fields and then produces a single URL which actually goes through all these, which actually then enumerates all the various items that we can have. So the items here are listed as t-shirt and drill and lock set. And we have names, we have Jane Doe and John Smith, and we have cities such as Seattle and New York. We have zip codes. What is a zip code? A zip code is 5 digits. Very simple. And each digit is a digit between 0 and 9. And if you use this order grammar, you're going to get plenty of URLs that come up with all sorts of various various values. And if you use this, put this into a grammar fuzzer for fuzzing, then this is one of the, and these are some of the orders you're going to, some of the strings you're going to get. And of course, you can feed all of these into you can feed all of these one after the other into the URL, and then fuzz with, well, regular values. However, you can also go and fuzz with unexpected values, of course. And for this, we are using one of our mutation fuzzers that we can easily apply to the individual values that we're having in here. And if we use one of these mutation fuzzers, then we're going to get email addresses like instead of Jane Doe, we get .doe, or we get different variations in the zip code, and thereby come up with all sorts of various values. And interestingly enough, this way we're also going to get, at some point, we're going to get some internal server errors because we feed in values that are not properly validated. And the thing that we see in here is actually this is the error we get. The value name is wrong. And what is actually happening in here? What we see is we find out what's going on, and we see that our mutation fuzzer actually has changed the field name from name to NAE. It has removed a character, and this then results in an internal server error. Building a web browser that gives you all sorts of details like this, a traceback of the code that is being executed, everything that goes wrong, is a neat idea because, of course, it tells you as a programmer everything that has gone wrong. But it's also a very bad idea because it also tells the attacker lots of details about your internal arrangements. So in our case, what we see here, just for the fun of it, is so an attacker would actually learn here the full SQL command that is being produced here. So the attacker learns, oh, we're using a SQL database. Oh, the database is named orders. That's very helpful. Oh, there's an item field, a name field, an email field, a city field, and a zip field. Yep, all of this information can be very helpful. And if you're a smart attacker, you're going to use later on this information to maybe create some SQL injection or like thing. And yep, this is all the fun in this chapter. And in the rest of the chapter, you're going to learn how we also extract such grammars from the forums, such that you don't have to write them yourself. So what we're doing here is we are actually parsing the HTML. We're looking at all the individual fields in the web form on the forum. And yes, if we find an input tag, then we save the type. If we find a select tag, this is for selecting from a menu. We save the individual values. So we actually go through all the individual HTML parts in here using the HTML parser, and then we save the name of the field, and we save possible values for that field. And here are actually the fields that we get for the web browser, for the fuzzing book swag browser. So we have items, we have a choice of items, we have a name, which is a field of text, we have an email, which is a field of type email, and so on. And from these, we can then create a grammar. And this grammar starts with a couple of generic parts. So it comes up with generic types for instance, what does an email look like? An email is a string followed by an @ sign, followed by another string. It also has a rule for a password. Unfortunately, we cannot guess passwords, so it simply comes up with a unique password, and it always enters the same password. We could be smarter than that at this point. And it also fills in numbers and text and everything. And this is now being extended by additional rules for the individual fields. And what we have here, for instance, this is now a full-fledged specialized grammar for this very form. And what we have here is the item, for instance, is filled with item value, and the item value is either t-shirt or drill or lock set. And then we can go and actually create arbitrary inputs, which now says the item is a drill, the name is, what is that? ++%61. If only I knew what %61 is at this point. The email is %6e at, that's something I know, %40 is an at character, at B+, at B++, very interesting. The city is 0, the zip is 88, and yes, we press the submit button, which of course is lots of fun because then you're going to get very interesting names and zip codes. Well, zip code isn't okay-ish, and also very interesting email addresses. And this grammar is something that we automatically get from a given web form. So what we need to do, all we need to do is we surf to a particular page, we have a form, we extract the grammar for this one, and then we pump in, and then we go and pump in all the individual values. Well, why doesn't this work in practice? Well, it works if you have a rather naive web server, but I can tell you right away that if a place like, again, Amazon detects that there is one single IP which orders hundreds of things per second, or anyway produces hundreds of requests per second, they're simply going to block your IP and be done with it. And even if you orchestrate a multitude of clients around the world, then they're going to notice, oh, there's hundreds of orders originating from one single account, and then, well, they're also going to keep you out. And if you come up with a multitude of accounts, they're going to notice, oh, there's hundreds of accounts being created from a single IP, and with all the same payment and maybe different credit cards, then you're going to need 100 different credit cards, and at this point it becomes really, really complicated. Sometimes you really wonder when you look at comments on posts and what's going on Twitter and likewise. Sometimes you wonder how many of these were actually produced by real humans. And yes, grammars are great tools also for creating all sorts of offensive messages. So come up with a grammar for the worst insults, for instance. And you can make use of that again and again, just for the fun of it. Okay, good. So I think I'm too creative here. Let's not do this. Okay, and what we're introducing here is now a web form fuzzer, which actually is combined with a web runner. So we directly feed in things directly to the current page that we're having here, and we're having plenty of fun. The actual implementation is slightly limited though. There's only one form per page, so not multiple forms, okay, that's simple. And it's also limited to get actions, that is inputs that are encoded into the URL. There are more ways to submit things in a web form. There's also post actions, that's also true. And it also only does HTML. There's no support for JavaScript forms whatsoever. So nothing like that, nothing like this either. Later on in the chapter, you're going to see how to crawl through multiple pages, which is actually fun, because what we're doing here is we are looking at all possible pages that we can find, meaning that you're not only going to fuzz one single form, but of course you're going to check an entire site for all sorts of forms that you could find. And you're going to search for forms everywhere. So here we have a crawler actually running on the fuzzing book. And what you see is how nicely it crawls through all the individual chapters, one after the other, which is plenty of fun. And then you can create tests for every single form that you find. And since we are using fuzzers for security purposes and to find security leaks, let me give you a brief idea on actually showing you how to synthesize common attacks also with this kind of fuzzer. And one very simple approach here is actually to is actually when you're entering information in a form to actually also include information that will then be interpreted again when it's being displayed. So a very simple way to put in extra information here is, for instance, after your name, you put in some HTML code, which in this case allows you to click here for cute cat pictures, and which points you to a special site, lots of malware. While you read this, you may just as well, rather than including HTML here, you may also include some JavaScript, and this JavaScript will then happily come up with then get extra information or come up with extra pop-up windows and whatnot. And yes, you can go and insert this into the database. This is what this looks like. So this is the URL, which then happily encodes all the HTML that you just entered. And if you do that, then you're going to have plenty of nice effects. And for instance, the log will all of a sudden contain links for cute cat pictures, because the log would also, well, be interpreted as HTML, would now contain this link. And of course, anyone at any point, whoever looks up the name of Jane Doe, and this shows up in an HTML page, will automatically also get this link, click here for cute cat pictures, because it's stored together with the HTML and the cute cat pictures link in the database. Yep, it will stay there forever. Even if you're an admin and you're trying to find out, hey, what's going on there, and you will always get this link, whatever you do. Ooh, yep, this is called HTML injection, and it's lots of fun. And if you ever wondered why it's typically not allowed to enter certain characters as part of your name, such as less than characters or quote characters or semicolons or likewise, or then, this is precisely to prevent you against this kind of attack. Or what you also can do, of course, is to sanitize these inputs, that is, properly escaping them, either when reading them in or when printing them out, which of course our naive web server does not do, because it is specifically built for the purpose of being able you being able to hack. And this is one thing. The other thing, which is also fun, is cross-scripting attacks. Cross-scripting attacks means that we are inserting code into a web page that automatically scans the rest of the page for embedded HTML. So, for instance, to steal cookies from your site, yet another option for you to actually retrieve information. What we're doing in here is, I'm not going to show you this right now. What we're doing here is, we are extracting a cookie from the document, which happens to be the cookie from our current Jupyter session, which actually means that if you do this, if you execute this code, then other people would then be able to steal your Jupyter session and interact with your code. Oh, that's also very funny. In particular, since your Jupyter lab server may actually be running remotely. And if people have the IP and if people have the session ID, then they can have fun with that. Ah, yeah, all the joys of cross-site scripting. And finally, we've seen this before, I think. Then there's of course also the wonderful world of SQL injection attacks, which allow you to put in specific values into your into the input, specific values that then would be interpreted possibly as a part of a SQL database command. Here, for instance, what we're doing here is we are defining this super special name, which consists of Jane, quote X, closing parenthesis, semicolon, delete from order, semicolon, dash, which, by the way, is a string that is very, very difficult to synthesize for a regular fuzzer. No, unless the fuzzer knows how to do things. We come to that in an instant. And the interesting thing is, if you place this as your name in the actual SQL command, what's going to happen is you're going to get this string here. You're going to get insert into order values. First we have the item, the t-shirt. And now we do have the name, and the name starts with Jane, quote, XX, quote, X, delete from order. So all of this here, from here to here, is supposed to be the name. That's fun. But what the SQL server is going to see is a command that starts here and actually ends here. Because there's first a command insert into orders, and that is actually syntactically valid in here. Wonderful. And then we have a second command that's being executed that says delete from orders, whose effect it is that all the columns in the database or the orders will actually be gone. And whatever is left in here, Seattle, whatever, is actually becomes a comment for the SQL server. And yes, this is of course somewhat risky because, well, you can happily do that in your grammar fuzzer, insert appropriate rules in here, such that the name of a particular person should always be Jane XXX, delete from orders and whatnot. And then when you're actually accessing the individual items, sending over this URL, then the effect of this will be that the orders will be deleted, which we actually can. Here we see the actual command being executed on our server, XXX delete from orders. There we go. And after that, the orders database is empty. Here we do have a very nice XKCD comic, which has become very, very popular to illustrate these dangers. Hi, this is your son's school. We're having some computer trouble. Oh dear, did you break something? Anyway, did you really name your son Robert, quote, parenthesis, semicolon, drop table students? Oh yes, little Bobby Tables, we call him. Well, we've lost this year's students' records. I hope you're happy. And I hope you've learned how to sanitize your database inputs. Yep, this is how you do, folks. And yes, if you are able to come up with such names and feed them into your web form and they're not properly sanitized, yes, all of this is going to happily break. And if you do have a web fuzzer, then you don't even have to try this out by typing this in and see what happens. No, you're just going to fire up your specialized web form fuzzer that automatically fills in all sorts of random SQL commands at all various places. And yep, sure, just let it run all day long. Give it one query per second, over here, over there, what happens? Yeah, sure. And yes, you may well create havoc this way. This is the sad reality. This is the sad reality of the web today. Good news is that if you're a good web developer, then you're having some penetration tester actually checking this out for you, checking out your web page for common errors. The bad news is I'm not really sure whether the web pages, the web servers of the world are actually prepared for fully automatic attacks. Okay, and this is essentially what we're having in here. Fully automatic attacks. Here we have here we actually have implemented this with a number of common attacks just for the fun of it. And yes, you can unleash this onto if you have a web server that you always wanted to check, such as your own in particular. Do not use this on any remote web servers, very obviously, because otherwise you will go to jail. You're not going to be able to use your get out of jail free card simply because you could say your professor in the fuzzing book told you so. No, I'm not telling that. But this just gives you an idea of what powerful weapons can be, what powerful weapons we have as it comes to fuzz applications.